Okay, so we're starting off with two equations. Cosine theta times cotangent theta times sine theta times cotangent squared theta plus 1 over tangent squared theta plus 1. And we're trying to prove that this equals 1 minus sine squared theta times sine theta over 2 sine theta cosine theta. So we're going to start off with the first equation, and we're going to start off trying to simplify cosine theta times cotangent theta times sine theta. So we know we have cosine theta times cotangent theta, and we know that cotangent theta equals 1 over tangent theta, and 1 over tangent theta equals 1 over sine over cosine theta, and that equals cosine theta over sine theta. So we have cosine theta times cosine theta over sine theta plus sine theta plus sine theta. Now we can multiply the two cosines together to equal cosine squared theta over sine theta plus sine theta. Now we need to get common denominators, so we multiply both sides of the sine theta by sine theta. So then you get sine squared theta over sine theta, which equals cosine squared theta plus sine squared theta over sine theta. Now using our identity of our Pythagorean identity, we know that sine squared theta plus cosine squared theta equals 1. So it becomes 1 over sine theta. Now that's for our first part of our equation. So now we know that 1 over sine theta times times cotangent squared theta plus 1. And by using our identities, we know that cotangent squared plus 1 equals cosecant squared theta. And that's over tangent squared theta plus 1. And using our Pythagorean identities, we know that tangent squared theta plus 1 equals secant squared theta. So now we have 1 over sine theta times cosecant squared theta over secant squared theta. Now we can simplify this by multiplying the cosecant squared theta by the 1 sine theta, so it would be cosecant squared theta over sine theta over secant squared theta. Secant squared theta. So now we know that cosecant squared theta equals 1 over sine squared theta. And then we leave the sine theta, so that's over sine theta. And then we can change the secant squared theta into 1 over cosine squared theta. So our sine squared theta and our sine theta cancel out, so it leaves us with just 1 over sine theta. Over 1 over cosine squared theta. Now we can flip and multiply. So we have 1 over sine theta times cosecant squared theta over 1, which becomes cosecant squared theta over sine theta. So then our answer for that is cosecant squared theta over sine theta. I mean cosine squared theta over sine theta. So that's our simplified equation for the first one. Now we have to try to prove that our second equation is equal to that. So our second equation is 1 minus sine squared theta times sine of theta over 2 sine theta cosine theta. Okay, so now on the denominator, using our identity of a double angle formula, we know that 2 sine theta cosine theta equals sine of 2 theta. So we can change our denominator to 2 sine theta cosine theta. 2 sine theta. Okay, and then on the top, we know that 1 minus sine squared theta is equal to cosine squared theta. So now we have cosine squared theta times sine theta. Cosine squared theta times sine theta over 2 sine theta. Now the sines can cancel out, which leaves us with cosine squared theta over just 1 sine theta. And that is how you verify 2 equations, which leaves us with cosine squared theta over sine theta equals cosine squared theta over sine theta. The end.